Hello. Good evening, everyone. So, tutorial number 7, chemical calculations, tutorial number 7. Question 15. So, I'll write it. Tell me whether you can hear me, all right? So, calculations, tutorial number 7. We came up to question number 14, I think. 15. Okay. Shall we start? 15, 16, 17, 18, 19, 20, right? Out of that, if there are kind of ones that are easy, if you don't want to discuss, tell me, right? Ones that are difficult and things that you need to really discuss, you can look at it. We can do that. So, shall I start with question number 15? Calculate the molarities of iron 2 and iron 3. Now, this is the third time I'm doing a similar question like this. There are two solutions, two cations. One is Fe plus 2, the other one is Fe plus 3. These are the two things that are there, Fe plus 2 and Fe plus 3. And you want to determine the concentration of these solutions, right? 20. Now, the reaction is given to you, right? Permanganate. This is the reaction. We will copy down the reaction. Permanganate is given. Write 8H plus in the acidic medium. It will react with 5Fe plus 2 to give you, what does it give you? It gives you Mn plus 2 and then 5Fe plus 3 and also it gives you 4 water molecules, OH2. So this is your reaction, right? 25 milliliters of the original mixture was acidified with dilute sulfuric acid and required 22 potassium permanganate. So potassium permanganate, you need 22.5 milliliters of 0.02 molar KMnO4. So that is needed to react with Fe plus 2 here, this material. Fe plus 2 is the one that will react with this. That is the one that will react with this. Right. Okay. So then further 25 milliliters of the original F iron 2, iron 3 mixture was reduced by zinc and acid. Then it requires 7.6 potassium permanganate for complete oxidation. We will come to that later. First, we will work on the Fe plus 2, the remaining Fe plus 2. So you can see number of moles of Fe plus 2 to number of moles of permanganate. What is the stoichiometry? So straight away, without writing anything else, you work on the stoichiometry. 5 is to 1. 5 is to 1. So what is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5 times permanganate. 5 times permanganate is 0.02 molar times 22.5 10 to the power minus 3. This is the number of moles. You don't forget the unit. Very important, right? So what is that? 5 times 0.02 times 22.5 10 to the power minus 3 is equal to 2.25 10 to the power minus 3. So 2.25 10 to the power minus 3 moles. So like nothing else. You don't have anything else. So what is the concentration of Fe plus 2 in the mixture? Number of moles divided by volume. What is the number of moles? 2.25 10 to the power minus 3. What is the volume? The volume that you have taken is 25 milliliters. 25 10 to the power minus 3 cubic decimeters. Right? So kind of get a hold of these calculations. I have done a lot of calculation with your 2.25 divided by 25 is equal to 0.09. Concentration is 0.09 moles per cubic decimeter. Right? Okay. Now what is the next thing that you do? A further 25 milliliters. Now this solution, another 25 milliliters of the original mixture was reduced with zinc. I have given you that reaction one day, right? So what will happen is Fe plus 3 is the oxidized form. Fe plus 3 is going to react with zinc. Zinc is more reactive. So it will give you zinc plus 2. Fe plus 3 turns into Fe plus 2. Right? So this is 2, this is 2. 2 times 2, 4 plus 2 is 6, 2 times 3, 6. So that reaction take place. All of these Fe plus 3 now turn this into Fe plus 2. So you have Fe plus 2 here, and original Fe plus 2 is also there. Original Fe plus 2 is also there, right? Original Fe plus 2 means this Fe plus 2. And the Fe plus 2 that was formed due to Fe plus 3. So everything now reacts with potassium permanganate. Again with the same reaction. Stoichiometry is the same. So number of moles of Fe plus 2 divided by number of moles of permanganate. What is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5. Number of moles of permanganate is 1. This Fe plus 2 that is reacting now is the original Fe plus 2 and the Fe plus 2 that was formed from Fe plus 3. Both are there. වර්ග දෙකම තියෙනවා. Both are there. So what is the number of moles of Fe plus 2 here? Is equal to 5 times number of moles of permanganate. Concentration 0.02. What is the volume? Volume is 37.6. For the second titration, it was 37.6. 10 to the power minus 3 moles. So what is that? 5 times 0.02 times 37.6 10 to the power minus 3. Then you get 3.76. 10 to the power minus 3 moles. So this is the number of moles of Fe plus 2. But then you all understood in the original sample, Fe plus 2 was this amount. 25 milliliters, 25 milliliters, they both have the same amounts. So you have to subtract that to give you the number of moles of Fe plus 2 formed by Fe plus 3. So this is, what is this number of moles of Fe plus 2? Now this is the number of Fe plus 2 original plus the number of moles of Fe plus 2 from Fe plus 3. Both is equal to 3.76. But then you know the number of moles of Fe plus 2 from the original sample. What is that? 2.25 10 to the power minus 3. Then do you understand what is the number of moles of Fe plus 2 formed by the Fe plus 3? This part. What do? You subtract. You know the total amount. From that you subtract. So let us say number of moles of Fe plus 2 from Fe plus 3. Is equal to 3.76 minus 2.25. 10 to the power minus 3. So what is that? 3.76 minus 2.25 gives you 1.51. 10 to the power minus 3. So this is the number of moles of Fe plus 2 from Fe plus 3. Did you all understand that? Now, you know if Fe plus 2 is formed, this is 2 is to 2. Number of moles of Fe plus 3 are also same. The number of moles of Fe plus 3 is the same amount. 1.51 10 to the power minus 3. What is the concentration then? Concentration of Fe plus 3 is equal to number of moles divided by volume. Here, what is that? 1.51 10 to the power minus 3 divided by volume 25. 25 10 to the power minus 3. So what is the value? 1.51 divided by 25 is the answer. 0.060. 0.060 moles per cubic decimeter. Did you all understand that? Everybody understood this? How to get that? Right? Whichever complex questions are there at the exam, like, based on this. Yeah, yeah. Okay. Any method, but you should get the right answer. May answer can, like, if you don't get this answer, that is wrong. මොකක් හරි වැරද්දක් ඇති. If you don't get this. But then if you get this answer, that's okay. Whatever the method that is convenient for you. Is it clear? Question number 15. Everybody got that? Right. Then shall I do question number 16? මොකද කියන්නේ? Is it difficult? Is it easy? Or if it is easy, we don't have to discuss that. But if it is difficult, we will look at it. කොහොමද? Everybody understood this? All of you children? Right. Yeah, clear? Right. Points, I got 0.0568, but there might be something wrong. Right? That's quite a deviation. 0.0568 it's like some kind of a deviation is there. Right. Right. Question number 16 then. Let us work on question number 16. A piece of rusted iron was analyzed to find out how much of iron has been oxidized to rust. Hydrated iron 3 oxide. Let us say you have a sample. Now, part of it is rusted. This is your rust. Part of it is rusted. So, this is still iron. This one is called iron 3 oxide. Fe2O3 dot H2O. Hydrated something. A small sample of the rusted iron was dissolved in excess dilute sulfuric. Right. Make aragena, you dissolve it in sulfuric to give a 250 milliliter solution. So now the volume is 250 milliliters. Right. The solution contains Fe plus 2 from the unrusted iron dissolving in the acid and Fe plus 3 from the rusted iron. So this solution contains Pudha Fe plus 2 and Fe plus 3 both. Fe plus 2 comes from the unrusted part. Fe plus 3 is the rusted part. You can see in here, look at this one, look at my laser pointer, I'm talking about this one. The oxidation state of that material is plus 3. Plus 3. This is Fe. Since Fe react with sulfuric, can you remember I told you last week in SPD block elements, whenever a metal react with sulfuric, it dilutes sulfuric, it gives out hydrogen. Dilute sulfuric act as a normal oxidizing acid. It gives you the normally lower oxidation state, Fe plus 2. Right? Okay. So that is Fe plus 2. That's how the reaction actually has worked. 25 milliliters of this solution, may solution again, right? So you take 25 milliliters of this solution. Required 16.9 milliliters of 0.02 molar KMnO4. KMnO4 complete reaction. Calculate the moles of Fe plus 2 ions in the sample titrated. Right? They are not talking about 250 milliliters. They are asking the number of moles of Fe plus 2 in the sample that is titrated. They are very easy question, right? So you can see number of moles of Fe plus 2 to number of moles of permanganate, MnO4 minus, what is that? Fe plus 2 is, you can see 5, right? Look at the equation given, permanganate is 1. Based on the equation given, you can look at number of moles of Fe plus 2 is equal to, what is that? 5 times permanganate, 5 times 16.9 10 to the power minus 3 multiplied by 0.02 0.02 moles. That's what we get. So what is that? 5 times 16.9 10 to the power minus 3 multiplied by 0.02. 1.69, 10 to the power minus 3. That's okay now. Now they should be kind of easy for you, right? These redox reactions, huh? Redox reactions and calculations based on that, right? Okay, right. Okay, question. Let us look at question number 17. Now, since that is a easy question, we'll move on to the next one, huh? Very quickly. Right. Question number 17. Read the question. 25 milliliters of an iodine solution. Now, we didn't do iodine questions for a long time. Let us see that. 25 milliliters iodine solution was titrated with 0.1 molar sodium thiosulfate. This is your solution. This contains iodine, right? And 0.1 molar sodium thiosulfate Na2S2O3 solution. And 17.6 thiosulfate milliliters are required. Milliliters were required. Give the equation for the reaction. Right now, you all know iodine and thiosulfate iodine, Na2S2O3, thiosulfate. Iodine turns into I minus sodium iodide, NaI. Thiosulfate turns into tetrathionate, Na2S4O6. Tetrathionate. This is 2. This is 2. 2 times 2, 4. Right. So that is your reaction. Right. Give the what is the indicator used and describe the endpoint in the titration. What is the indicator used here? Can we? Can you please keep the? And don't worry about the exam. We'll look at that later. Make a then focus on this. Right. Okay. Right. Will the questions be given at the exam more harder than? Yeah. There will be like, the in the exam questions, this is what you should like, take exam papers and look at them now itself. හරිද? ඔයා කරේ නැති වුණාට ඔයාගේ යාළුවෝ කරනවා. Right? That's what I think. Right? Okay? If you are not doing, you are the only person not doing it. So look at the papers and look at see how things are. You get the same questions, but lot of material being given to them and then asking you to analyze it and do it. Right. So what is this? Can you tell me now? Answer these questions. What indicators are used? What is the indicator that is used, and what is the endpoint at the indicator? What happens in this one? If you look at the indicator here, when you do what is starch is the one that is used as an indicator. Starch is the indicator. But you should not add starch at the very beginning, right? You add starch at the very end until it becomes yellow in color. Very light yellow in color. Otherwise, it forms an insoluble iodine complex. And what will happen is you get an error in the titration. So you add a few drops of starch before, after it becomes light yellow in color or hay yellow in color or straw yellow in color, where you get this very intense colored solution, right? Blackish blue color solution. And then you continue the titration until it becomes colorless. So when you say describe the endpoint of the titration, that is what we need to look at, right? So you add starch when it is hay yellow in color. When it is hay yellow in color. HAY yellow in color. Right? It becomes blue-black in color. Continue the titration until it becomes colorless. Right. So that's the idea that is there. Right. Okay. Good. Very good answers. Right. Calculate the concentration of iodine in moles per cubic decimeter and grams per cubic decimeter. Let us do that. So what is this iodine? So number of moles of iodine to number of moles of sodium thiosulfate, Na2S2O3. Right? Iodine is 1, sodium thiosulfate is 2. So what is the number of moles of iodine? Number of moles of iodine is equal to number of moles of sodium thiosulfate, Na2S2O3 divided by 2. What is the number of moles of sodium thiosulfate? 0.1 times 17.6 10 to the power minus 3 moles divided by 2. So that's your answer. But 0.1 times 17.6 10 to the power minus 3 divided by 2. That gives you 8.8 10 to the power minus 4. Calculate the concentration. So this is the number of moles. 8.8 10 to the power minus 4 moles. So what is the concentration? Concentration is equal to number of moles divided by volume. What is the number of moles? 8.8 10 to the power minus 4 moles. Volume. What is the volume? Volume that you have taken is 25. 10 to the power minus 3 cubic decimeters. A divided by 25 10 to the power minus 3 is equal to 0.0352. 0.0352 moles per cubic decimeter. Are it clear that? Did you understand that? Everybody understood that. 0.0352, right? And then you have to convert this into grams per cubic decimeter. Convert it to grams. So how do you look at the concentration of iodine in grams per cubic decimeter? You get 0.0352 multiplied by molecular mass of iodine 127 times 2 grams per cubic decimeter, right? So what is that? 127 times 2 is equal to 8.94. 8.94 grams. What is the answer? Ah, yes, grams per cubic decimeter. Everybody understood that? Purplish blue color කියලා ගන්න නැහැ. එහෙම ගන්න නැහැ. Purplish blue color කියලා නෑ. It's like bluish black color. Right? Y2 කියන්නේ මොකද්ද? Y2 කියන්නේ? Y2, what do you mean by Y2? Right? මොකද්ද Y2 කියලා කිව්වේ මොකද්ද පුතා? What do you mean by that? Y2. Y2 can hear the 2. This one. Okay, iodine is I2. One iodine is 127. I2 කියලා කියන්නේ 127 times 2. That is the molecular mass. Right? Okay. Right. Is it clear? Right. Okay. Right. Okay. Now let us do, right, that is question number 17. Right. Let us do question number 18. Right. Okay. So question number 18. If you want to get it explained, then may වෙලාවේ ඒක කරන්න බැරි වෙයි. Like, you know, I might not be able to explain it. So you have, when this is uploaded, you can watch it again. Because otherwise it is like a kind of a waste of time of everybody. Then make a parak කිව්වහම, right? If I am explaining it again and again, it's a waste of time of everybody. If you can ask me like the specific questions, I will be able to answer that. Right? Okay. Question number 18. I mean, this part I don't understand. This part I don't understand. Right? Right. Okay. Question number 18. Ask something to relate with the time with them, because maybe 1 hour, like, we should not waste time. Right. Question number 18. 1.01. Now focus on this. 1.01 grams of an impure sample of potassium dichromate. K2Cr2O7. That is 1.01 grams. Impure. It's not pure. It's an impure sample. Right? Was dissolved in dilute sulfuric and made up to 250 milliliters. So you make it acidic, H plus, and you prepare 250 milliliter solution. 25 milliliter alicate of the solution was pipetted out. So 25 milliliters of this solution is taken into a conical flask. Excess potassium iodide solution and starch indicator was added. So you add Ki here. Excess, and starch is also added. The liberated iodine was titrated. So it gives you iodine titrated with 0.1 molar sodium thiosulfate. And the starch turned colorless after adding of 20 milliliters. And that's it. And then you have to understand the question. But potassium dichromate 1.01, it's not pure. And you add acid and you make it to 250 milliliters. Out of that, you take 25 milliliters and excess Ki. Then it generates iodine. Iodine was reacted with 0.1 molar sodium thiosulfate. 20 milliliters was required. Construct the full balance equation for the reaction between dichromate ion and the iodide ion. That's the first thing that they ask. Dichromate ion Cr2O7 2 minus plus iodide ions I minus. What will happen to I minus? I minus turns into iodine. How do you know that? It says, iodine is there. Dichromate turns into what? In the acidic medium, it turns into Cr plus 3, which is green in color. Right? That's the reaction. So plus 6 turns into plus 3. How many electrons? 3 electrons altogether, 6 electrons. Because there are 2 atoms. I minus to iodine, 1 electron. Since there are 2 atoms, you have 2 electrons. Multiply this by 3. You multiply this by 3, this by 6. This is 2. In order to add water molecules, 7 water molecules, 7 times 2, 14 H plus. If you do it right, that means the charges should be balanced. But plus 14 minus 2, 12 minus 6 plus 6, 2 times 3 plus 6. I hope you got the idea. Good. Very good. Now that reaction takes place. Reaction. That's all. Write the balanced redox reaction for the reaction between thiosulfate ions and iodine. You know how the reaction takes place. Iodine plus, if you want, S2O3 2 minus thiosulfate turns into tetrathionate, S4O6 2 minus, plus iodide. Now this reaction takes place. Thiosulfate and iodine reaction. That's okay. Right. Now they say calculate the moles of sodium thiosulfate used in the titration, hence the number of moles of iodine titrated. So what is the first one? Number of moles of thiosulfate used. What is that? Concentration times volume. What is the concentration? Thiosulfate is 0.1. 0.1 thiosulfate, 20 milliliters. 0.1, 20 milliliters. 20, 10 to the power minus 3 moles. That is equal to 2, 10 to the power minus 3 moles. Thiosulfate is this. And then they say, hence the number of moles of iodine titrated. You can see the number of moles of iodine to number of moles of thiosulfate is 2O3 2 minus is equal to what? Iodine is 1. Look at the stoichiometry. What is there? Just the ratio. 1 divided by thiosulfate is 2. What is the number of moles of iodine? Number of moles of iodine is equal to number of moles of thiosulfate divided by 2. 1, 10 to the power minus 3. So did you all understand that? Everybody, you got it? All of you? Anybody who didn't understand it? First part? Right, okay. Now, right, let us look at the second one. Second part. Second part. Calculate the number of moles of dichromate ion that reacted to give the iodine titrated in the titration. Now you can see we are now looking at this reaction, May reaction, because we want to get the relationship between iodine and dichromate. So dichromate is here, iodine is here. So you are going to look at that reaction, right? If iodine is formed, dichromate, how much of dichromate? Number of moles of dichromate, Cr2O7 2 minus. Divide by number of moles of iodine. Dichromate to iodine, dichromate is 1, iodine is 3. 1 and 3. So what is the number of moles of dichromate? Number of moles of dichromate is equal to number of moles of iodine divided by 3. 1 10 to the power minus 3 divided by 3. Is it clear to you? Did you all understand that part? But yes, sir, so that we can proceed. Hari? Everybody understood that? Right, okay. Right. Everyone? Okay, good. Very good. And well done. Very good. Hari. Good. So number of moles of dichromate is there. Right. Calculate the formula mass of potassium dichromate and the mass of it in the 25 sample. So what is the mass? Now this is in 20 milliliter sample, 25 milliliter sample. So mass is equal to number of moles times the molecular mass. What is the number of moles? 1 10 to the power minus 3 divide by 3. What is the molecular mass of dichromate? Right? 39 times 2 potassium. Dichromate 52 times 2 plus 16 times 7 gives you 294. Can somebody double check it and tell me? 294 grams. So that's what you get. So 294 times 110 to the power minus 3 divided by 3. So 0.098. Did you understand that? This is the number of moles of potassium dichromate in this 25 milliliter sample. Right. Then they say calculate the total mass original sample. Hence the mass percentage purity. What is the total mass of the original samples? Formula mass mass formula mass. The mass given by the formula. That is called the molecular mass. Because this is an ionic compound. Ionic compounds, you don't normally call it molecular mass because they are not molecules. Right? So usually you call them the formula mass. It's the most accurate term. So what is the fifth one is this. Did you understand that? What is the total mass? So what is the total mass? Total mass is given by here then. 0.098 in 25 milliliters, 250 milliliters multiplied by 10. 0.98 grams. 0.98 grams is that. And then what is this? What is the mass percentage purity? What is 1.01 is the mass that you have taken. 0.98 grams is there. 98 grams. If you take 1.01 grams multiplied by 100%. Right? Divide by 1.01 multiplied by 100%. What you get is 0.98 divided by 1.01. 97.0. That is your mass that you get. Haridana, very good. Right? Why did we multiply 0.0298 by 10? That is because, Bhuta, this solution has only 25 milliliters. For the titration, you took 25 milliliters. Original sample is 250 milliliters. It is 10 times the value. That's why. Yeah. Did you understand that? Everybody? Right. Okay. And okay, I think they're kind of very simple set of questions. Put a pattern. If you understand the pattern, it will become very easy. Right? That's the same question that is there. Right. Abi question number 19 also will do. Question number 19 as well. Right. This question involves titrating ethane dioic acid, oxalic acid. Again, what is the oxalic acid? H2C2O4. You are titrating oxalic acid with standard sodium hydroxide solution and then with potassium permanganate solution. This is this, right? So first one that you do is 10 milliliters of oxalic acid required 8.5 milliliters of 0.2 molar sodium hydroxide for complete neutralization using phenolphthalein indicator. So that's it. That's the first one. 10 milliliters use same oxalic acid solution required. The same oxalic acid required 8.2 milliliters of potassium permanganate. Acidify with ethanol solution. Write the equation for the neutralization reaction sodium hydroxide. Did you understand that? I'm just looking at some of these answers, the questions to see. Right? Okay. So is it clear? Did you understand that? Right. So let us look at the first one. Write the equation for the neutralization reaction. So H2C2O4 plus sodium hydroxide. What would you get? You get sodium oxalate, Na2C2O4 plus, what is the other one? Water. Right? So here 2 sodium, hydrogen 2 here, this is 2. So that's your reaction. Right? Neutralization reaction is that. The first one. Second part. Calculate the moles of oxalic acid in the solution and the molarity of the ethanoic acid solution. Right. So number of moles of oxalic acid to number of moles of sodium hydroxide. Number of moles of sodium hydroxide. What is that? Oxalic acid to sodium hydroxide stoichiometry is oxalic acid is 1, sodium hydroxide is 2. Right? Oxalic acid concentration, C, what is the volume? 10 milliliters. Sodium hydroxide concentration is 0.2 moles per cubic decimeter. What is the volume? 8.5 milliliters. I can substitute in milliliters because like, the milliliters cancels out. Never cancels out. So what is the concentration? Concentration is equal to, make a 2 and this is 0.1. 0.1 again, 0.85 divide by 10. You get an answer as 0.085 moles per cubic decimeter. That is your answer. Did you all understand that? Is it clear? Everybody got it? That is the molarity. Molarity means concentration. Concentration of this acid is that. Everybody got it? Right. Others also. Then product, you have to do it on your own as well. I really don't like when people just complete the note when I am doing it. You write it anyway. But some others, people write it like that. I don't like that. What will happen is because what I write, you write. You think that was done in grade 1. Teacher write letter A, student also write letter A. But how do you become better at writing letter A? Practicing on your own. Make a verdi karandu. Right? That you have to do it. That's why these answers are given. So you can progress. Right? Why am I doing this? Just to those who couldn't do it, product stuck in help back with right? Ideally, you should progress forward. Then this is what you have. That is B. Calculate the moles of solution. Write the full redox titration equation for the oxidation of ethane dioic acid by potassium permanganate. So you have H2C2O4, H2C2O4. And then permanganate MnO4 minus. Turn this into Mn plus 2. Oxalate ions, you turn this into carbon dioxide. What is this? Plus 3 turning to plus 4. 1 electron, that is altogether 2 electrons. This is plus 7, this is plus 2, 5 electrons. This is what you have, 5 electrons. 5 electrons, multiply this by 2. Yeah. 5 multiply this by 2, this by 5. So this is multiplied by 2, this is multiplied by 2, this is by 5. 5 times 2, 10 CO2. Right? Then how many H pluses? Minus 2, 2 times 2, 4, 6 H pluses. 6 H pluses means 5 times 2, 10. 10 plus 6 is 16. That means you need to have 8 H2O on this side. Right? Right. So if you want to write the entire reaction, you can do that. H plus means sulfuric. 3 sulfuric. Mama nikal liyanna. 3 sulfuric. How do you get 6H plus? By adding 3 sulfuric. 5H2C2O4. 2 KMNO4, potassium permanganate. Now you all see 2Mn plus 2, 2 manganese sulfate. No other anion is present. 10 CO2. And then 8 H2O. How many potassium? Here you can see 2 potassium here. Altogether 2 potassium here. And you get K2SO4. So you can see all the sulfates. Here 2 sulfates. And here the next sulfate. Altogether 3 sulfates are there. Right. Okay. From the equation in C and the titration data, deduce the molarity of the potassium permanganate solution. Right. So what is this? Number of moles of potassium permanganate to number of moles of oxalic acid. Number of moles of H2C2O4. What is the stoichiometry? Potassium permanganate is 2, oxalic acid is 5. 2 to 5. Now you all have calculated the concentration of oxalic acid, 0.085, right? 0.085 moles per cubic decimeter. What is the oxalic acid volume that you have taken? You have taken 10 milliliters. They say same volume, 10 milliliters. Concentration of potassium permanganate is what they ask you to calculate. The volume that you have taken for the endpoint is 8.20 milliliters is equal to 2 divided by 5. So you can see this, some of these things cancels out. What is the concentration? 0.085 multiplied by 10 multiplied by 2 divide by 8.2 multiplied by 5. 5, this is 2. So what is that? You get 0.085 times 4 divided by 8.2. What I get is 0.085, 85. Oh, yeah. Right. In 0.0414. Mega, what did you get? 0.085 or yeah, 0.085, right? This concentration, what did you get? Yeah, 0.0414. Yes. 414 grams remain moles per cubic decimeter. I think there's a decimal place missing. I think. What are your answers? Grams then, sir, 10 to the power minus 3. कोई एकदा पुता 10 to the power minus 3 की. What is that? Point zero. Right. Yeah. Okay. Right. Thank you. Thank you. This is correct answer. 0.0414 moles per cubic decimeter. 4146 415 කියලා ගත්තර But this is okay. අරක වැරදි. 0.415 කියන එක වැරදි. Right. Okay. There was a question. Somebody. Right. Okay. So everybody is like, somebody has asked one question and I missed it. කොහෙන්ද වන්ද නැති වුණා. What is that? Common question කියලා අහලා තිබ්බා. I don't know. Why potassium permanganate mentioned as potassium manganate instead of permanganate each and every. ඒක එහෙම තමයි. ඒක there are two ways of naming this. හරිද මෙතන like you have to understand that it says potassium manganate 7 කියලා තියෙන්නේ. Like it's not potassium manganate. It says potassium manganate 7. It's another way of saying this. Manganate 7 means oxidation number is 7. Oxidation number 7 means everybody knows it is MnO4 minus. The other one is MnO4 2 minus. Right? MnO4 2 minus is plus 6. That's also another way of saying this. Hurry. Right? Okay. Right. Yeah. Okay. So 2 decimal places is enough. Two decimal places is enough. අපි නිකන් question number 20 කරමු. Right? 20 question number 20 before we take a break. හරිද? Question number 20. Right. Let us do that. Let us read that question. Lone sand contains Fe salt iron 2 sulfate is used to treat moss. 2.5 grams of lone sand is the brand. මොනාරි brand එකක් කියලා හිතන්නකෝ. Right? Right, so here you get 2.5 grams of long sand mixed with dilute sulfuric. So H2SO4. Extract iron 2 salt, Fe2 plus. In a volumetric titration, it is required 24.5, 0.02 molar. 0.02 molar. K potassium manganate 7, KMnO4. How many milliliters? 24.5 milliliters. Fully oxidized. Write down the equation for the redox reaction. Fe plus 2. Blue and name, right? Fe plus 2. And permanganate, MnO4 minus. MnO4 minus turns into Mn plus 2. Fe plus 2 turns into Fe plus 3. Right? Maker, this is 1 electron. This is 5 electrons. Multiply this by 5. 4 water molecules. 4 times 2, 8H plus. That's okay. Right. So what is the next one? Calculate the percentage by mass of Fe plus 2 in this sand. Right. So number of moles of Fe plus 2 to number of moles of permanganate is equal to, what is that? 5, Fe plus 2, 5, permanganate is 1. Number of moles of Fe plus 2 is equal to 5 times permanganate 0.02 times 24.5 10 to the power minus 3 moles. Right? 5 times 0.02 times 24.5 10 to the power minus 3 is equal to 2.45 10 to the power minus 3. Right? So if that is the amount of Fe plus 2. So let us calculate the mass. Mass is equal number of moles times molecular mass. Molecular mass. Right? Number of moles is equal to 2.45 10 to the power minus 3. Molecular mass, they have given it as 55.8 grams. So multiplied by 55.8. That gives you 0.136. So what do they ask? Calculate the percentage mass. Percentage mass. So what is the percentage mass? Is equal to 0.136 grams. Out of how many grams? 2.5 grams. Multiplied by 100%. 0.136 divided by 2.5 multiplied by 100% is equal to 5.44%. Did you get that? 5.4. 44 කියලා 1.4. Hari, everybody okay? Right. Then එතකොට now question number 21 to 28. But I want you to do it by next week. Mama, next week tamai, this is the last week I will do this tutorial. Make right 21 to 28. I will take some whatever the difficult questions next week. And then we will move on to question number 20, tutorial number 8. Tutorial number 8 is it's like they are coming from past paper questions, right? Various types of past paper questions. But next week is the last week I will do tutorial number 7. Then we will continue to tutorial number 8. But tutorial number 8 and gases, both, I will discuss some of the gases questions is also online. You have to kind of complete both of them, right? Starting from next week, right? Try to finish them because now we need to finish it, finish these tutorials and get on with the habit of working with energetics, working with SPD, and gradually phasing out to organic chemistry. හරිද? ඒකට අපි ready වෙන්න ඕන. So I have given no one has given this much of time for chemical calculations for you all to actually practice. I have given that, right? But then at a certain point, I have to move on. නැත්තම් අපිට බෑනේ. We get stuck. හරිද? ඒකින්ද right? So within like I give you another maximum 2 or maximum 3 weeks. Wow, make chemical calculation, all these questions you should finish. Right? හරිද? Right. Okay. එහෙනම් පුතා අදට ඇති. We will after 2026 people go to A levels, I will increase this time discussions. හරිද? එතකොට අපිට we can do multiple questions, better questions and lot of questions and become better. හරි? Right. Okay. Right. Take care පුතාලා. Bye. Thank you for joining. Right. Bye.